Why should you care about how your brain works? Asks John Rady, MD. Your life changes when you have a working knowledge of your brain. It takes the guilt out of the equation when you recognize that there's a biological basis for certain emotional issues. On the other hand, you won't be left feeling helpless when you see how you can influence that biology. With this idea as a guide, we will consider the science behind these basic questions. Are we stuck? Why is the sense of safety important? Where does a sense of safety come from? What does trauma do to that sense of safety? How does trauma-informed yoga put it all together and empower someone to get unstuck? Are we stuck? Are people stuck in trauma without the possibility of moving ahead to create better lives? Can someone build resiliency skills to buffer the effects of trauma? To explore these possibilities, it is helpful to understand the science behind both trauma and the healing benefits of yoga. That is, to have a working knowledge of your brain. Today's neuroscientists use brain imaging to support what some brilliant thinkers have researched and written about for over 100 years. William James, Ramon E. Cajal, Sigmund Freud, and Moshe Feldenkrais all considered that the human brain possesses the quality of plasticity, or the ability to rewire. Today, we call this property neuroplasticity. From this renewed appreciation comes a profound sense of possibility in our abilities to indeed grow and to change. Western science is now showing what other cultures have practiced for thousands of years, that connecting the mind and the body using the breath can help heal trauma and build resiliency. Let's explore the body physiology that creates these connections. We need to start with the basics, a working definition of a neuron. Neurons are cells found throughout the body, the brain, the skin, the muscles, and the organs, including the gut. Some neurons are sensory, relaying information from the senses in the form of electrical impulses. Other neurons are motor neurons, controlling all muscle movement in the body, both voluntary and involuntary. Neurons communicate, that is, send signals throughout the body using both electrical and chemical signals. A fun neuron fact: one of the smallest neurons is found in the brain. It's about 4 microns. A human hair is about 70 microns in diameter. The longest neuron is the sciatic nerve, and the axons can stretch over 3 feet in length, from the hip to the foot. Another fun neuron fact is that 80% of the neurons found outside of the brain are found in the gut. More on this relevant trauma fact later. Reviewing some neuron facts is important to understanding the trauma story. It makes sense that first we need to understand a healthy neuron. A neuron has several parts. The cell body, often called gray matter, containing the nucleus and the DNA, the dendrites, which receive the signal from other neurons, and the axons, which generate these signals. The axons are covered by myelin sheaths, the white, fatty material along the length of the neurons. Myelin can increase firing rates by up to 3,000 times. As you practice something, myelin is one reason your proficiency or speed increases. At the very end of the axons are vesicle sacs, in which neuromodulators are stored. When activated, such neuromodulators as dopamine, serotonin, and epinephrine, also called adrenaline, are secreted into the spaces between the neurons called synapses. Cortisol is a stress hormone that also can be secreted. Consider the numbers. The brain alone has over 100 billion neurons and trillions of supportive glial cells. Collectively, these neurons are over 200 million miles long. This means neurons in your brain would wrap around the Earth 8,000 times. There's more. Each neuron has an average of 10,000 connections to other neurons. When we talk about neuroplasticity, we're talking about changing both the structure and the function of neurons. An engaging new book that discusses the many possibilities about how a brain can rewire is Live Wired, The Inside Story of the Ever-Changing Brain by David Eagleman, a neuroscientist at Stanford. Brains, rather than being hardwired computers, are, as Dr. Eagleman suggests, live-wired, able to change and to grow in response to both internal and external stimuli. The idea that we are not hardwired has changed an age-old, often heated discussion of nature versus nurture. Who we are, and as importantly, who we can become, is now viewed by many as a dynamic interplay between genetics and experience, not as one or the other being the major determining factor. More as this relates to our trauma recovery discussion a bit later. The sense of possibility for change and growth is rooted in the understanding that neural connections can be strengthened just as muscles can be strengthened with use. An idea put forth in 1949 by a Canadian neuroscientist, Donald Hebb, stated that when we learn something, the connections between the neurons become stronger and faster, forming stronger neural networks. Carla Schatz, a groundbreaking Stanford neuroscientist, is credited with saying, "Neurons that fire together wire together," with the corollary, neurons that fire out of sync lose their link. Let's keep exploring the science as we gather ideas to guide our trauma recovery protocols. In 1990, Eric Kandel, MD, won the Nobel Prize for showing that the brain can change through two mechanisms, both thought and experience. So not only what you think, but your experiences or what happens to you change the brain at the cellular level. So neuroplasticity happens throughout the lifespan. The nature-nurture debate has indeed evolved. The brains with which we were born are only a starting point, for the brain changes as we continue to interact with the world and with each other. And the brains with which we were born may have been impacted by the experiences of our parents, as the new field of epigenetics continues to show. More on that later. It is this ability to change that continues to infuse the trauma recovery and resiliency discussion with possibilities. Norman Doidge, MD, explores the science and offers many compelling examples to create a book that will both inform and inspire anyone interested in helping others or themselves make meaningful changes in their lives. Ongoing research and discovery continue to shape the field of trauma recovery, framing clinical and teaching approaches around the science of neuroplasticity. So, are we stuck? Science clearly tells us that we are not. Before we spend more time on safety, let's take a short break. If you like, let's practice 3 shoulder rolls back. Always move in a comfortable way. As you breathe in, shoulders lift. As you breathe out, shoulders roll back and down. As you breathe in, shoulders lift. As you breathe out, shoulders roll back and down. As you breathe in, shoulders lift. As you breathe out, shoulders roll back and down. When you are ready, gently press one shoulder back, then press the other shoulder back. Now, if you like, put one or both hands over your heart. Put one or both hands over your heart. The suggestion is to practice 3 breaths. Feel the breath in. Feel the breath out. Feel the breath in. Feel the breath out. Feel the breath in. Feel the breath out. If you like, gently stretch the fingers on one hand or shake that hand. Then gently stretch the fingers on the other hand or shake that hand. Let your hands be as still as you would like them to be. If you like, give yourself a few moments to notice how you feel. Now on to the next section.